This video is called Laws of Logarithms, and we're going to look at those laws. There are 3 laws I've written out. I'll go through them one by one, and we'll look at an example for each one. The first law is if you have the log of something times something else, you can rewrite it as a log of the first thing plus a log of the second thing. Later you're going to use this for a whole bunch of different activities and different exercises, but right now let's just see that rule in action, just a simplification. Log base 5 of 12x, that's the same as log 5 of 12 plus log base 5 of x. And we're not going to go any further, it's just showing you that's how that law works. Here's another law in action, law 2. When you have log of any base a of x divided by y, that's the same as log base a of x, take away log base ay. Let's see an example. We have log base 2 256 minus log base 2 32. So by this rule, I'm going to go the other way. I'm going to use this side and change it to this. By this rule, if I simplify, that's log base 2 of 256 over 32. And I can even simplify further because now I've got 256 divided by 32, that's 8. So now I have log 28. And sometimes, depending on the activity or the question on the test, you'll be asked just to do that kind of simplifying. But if it says solve, I'll write here, now we're going to solve. If it asks you to solve, you can use Rule 9. I recommend looking at the Rules of Logarithms video. Rule 9 tells you can change this log 28 to log base 10 8 over log base 10 of 2. And notice you don't write the 10. You can. It's not an error. Log base 10, if you don't write it, it's implied it's log base 10. And the beauty of that is now you can use your calculator and go, what's log? Because your calculator's log is 10. So log base 10 8 divided by log base 10 2. And you get, of course, 3. So now you've seen a second law in action, this law. The final law is log a of x to the power of n is equal to the n becomes the coefficient of log ax. And here, instead of doing an exercise where we just simplify or where we simplify and solve, here I'm going to prove it to you. One example is never a proof, but you're going to see that the rule works, at least in this case. You'll have to trust me, or I can show you a full proof later if you want. So let's just look at it, evaluating it using the rules we already learned. So this is log base 3 of 4 to the power 5. On my calculator, what's 4 to the power 5? 1024. So this is log base 3 of 1024. And using Rule 9 again, that's the same as log base 10 of 1024 over log base 10 of 3. Now we can punch in our calculator, log of 1024 divided by log 3, base 10. I get approximately 6.309 after the 9's a 2, so rounded down. So let's make sure the other side works true. And notice this expression, I just brought the 5 down in front. It's the same thing, so you're sort of showing that this rule, at least in this case, works. Now the 5's in front, so let's do 5 times the log of base 3 of 4, which again using Rule 9 is log of 4 over log 3. And I'm going to compute that all at once. Start with what's in the brackets here. Log of 4 divided by log of 3. Notice I hit equals in between there. It just, some calculators you don't need to, but I always like to play it safe. Times 5. And I get again approximately 6.309. And so that's that law of logarithms. So here it is again, the law of logarithms. The 3 laws are: 1, if you have the log of 2 things times together, that's the same as the log of the first thing plus the log of the second thing. If you have the log of something divided by something else, that's the same as the log of the first thing, subtract the log of the second thing. And finally, if you have a log of something to an exponent, it's the same as the log of that something with the exponent as the coefficient, multiplying it. I hope you enjoyed Laws of Logarithms.